Introduction to hyperbolic functions. Hyperbolic functions and hanging cables. Hyperbolic functions are discovered by Vincenzo Riccardi. The hyperbolic functions are very useful in both mathematics and physics. In mathematics, hyperbolic functions are analogues of ordinary trigonometry or circular functions. The hyperbolic functions are hyperbolic sine is sine hyperbolic x equals 1/2 of e to the power x minus e to the power minus x, whereas hyperbolic cosine equals cos hyperbolic x equals 1/2 e to the power x plus e to the power minus x. Using this, you can also find tan hyperbolic x, which is sine hyperbolic x upon cos hyperbolic x. The equilateral hyperbola x equals cos h alpha, y equals sine h alpha. The graph of hyperbolic functions. Y equals sine hyperbolic x is given in the upper graph and y equals cos hyperbolic x is given in the lower graph. The St. Louis arc in the shape of hyperbolic cosine. The hyperbolic curves are very useful and regarded as very important factor to study. The curve formed by hanging necklace is called a catenary. This shape follows the curve of y equals cos hyperbolic x. Catenary curves. The curve described by a uniform flexible chain hanging under the influence of gravity is called catenary curve. This is the familiar curve of electric wire hanging between two telephone poles. The curve is described by a cos hyperbolic theta function. This graph represents sine hyperbolic x. Now here you can see the y equals tan hyperbolic x graph and y equals cot hyperbolic x and y equals cot hyperbolic x graph. This is the combined graph of sine hyperbolic x, cos hyperbolic x and tan hyperbolic x. And this is the graph of sec hyperbolic x and cosec hyperbolic x functions. And here are other useful relationships of hyperbolic function which you will get in the description or in the comment box. I will give you the PDF link of this file. These are some hyperbolic formulas for integration. Application of hyperbolic functions. Hyperbolic functions occur in the solution of some important linear differential equation. For example, the equation defining a catenary and Laplace equation in Cartesian coordinates. The latter is important in many factors of physics, including electromagnetic theory, heat transfer, fluid dynamics, and special relativity. Curves on roller coaster bridge is an example of hyperbolic functions. Thank you for watching. Please subscribe us for more videos like this.